quadratic sequences. One of the trickiest topics at GCSE, I think. You can, if you practice it enough, you can get around it there. You can like sort it. It's not that bad, but it's like understanding, I think that's the hardest bit. So the way I like to cover it is I like to actually use the nth term to work out the first few terms in terms of n. Or it's actually also, it's a quadratic, so first of all, find the first difference, 4, 10, 16, and then find the second difference, which is going to be 6. That kind of proves it's a quadratic. Right, first term, generally, is going to be when n is 1, and I substitute it in, I'm going to get a plus b plus c when I substitute n is 1 in. Second term, n is 2, I'm going to get a times 2 squared, which is 4a, b times 2, which is 2b, plus c, and then n is 3. Very similarly, I'm going to get 9a plus 3b, and I highly advise you learn how to do these steps and understand it as well. Then I find the first difference. It's going to be 3a plus b and 5a plus b. And then the second difference is this constant 2a, and it's going to be 2a every time. I've just realized, bear with me. I like to color coordinate what's going on. So these 6's are actually the green second difference, and this 4, 10, and 16 as this red first difference. And in blue is actually what maps with these numbers here. So first things first, I can write down that 2a equals 6 because that's the second difference for my quadratic sequence, and this is it in general. So a is going to be 3. Then I've got that 3a plus b is equal to 4 because that's my general first difference, and this is my actual first difference. First difference, I should say. But a is equal to 3, so it's going to be 9 plus b equals 4, and b is going to be minus 5. And then this final one, we've got that a plus b plus c must equal minus 1. So 3 minus 5 plus c is minus 1, or minus 2 plus c is minus 1. So c is going to equal 1. And that is my answer. Just for info, sometimes people learn these and they learn basically that they learn this, and this, which you can do. I don't recommend it. I recommend trying to understand it and be able to derive this, because this can be nicely extended to cubic sequences and so on. It even works for linear sequences. But then they forget actually what these things represent. And don't forget, this is our actual nth term. So if I was to, this is not part of the answer, but if I was to write down the nth term, it would be 3n squared minus 5n plus 1. And this is really powerful because I could now find the 100th term really quickly if I wanted to, or any term number, and then a bit more about the sequence.